This video is on area of a triangle where the height is not given and it is an application question. A regular pentagon is inscribed in a circle of a radius 8. Find the area of the pentagon. So the first thing and the easiest thing to do is to draw a pentagon which is inscribed into a circle and then indicate your radii, because that really is the only information that is given. So when we now look at this triangle, which has no perpendicular height, so we are going to work with the area of that triangle, then we can see the two sides and the included angle. And remember, the formula I told you to remember is that area equals a half, two sides, and then the sin of the included angle. All right? So when we look at this, we can have the sin of the angle theta. But now the problem is that angle is not given. However, if we look at this, we can see that theta is an interior angle, and we know that the center angles of any polygon is 360 divided by the number of sides. So that is 360 divided by 5, which gives me an answer of 72 degrees. So this angle is 72 degrees. Now to calculate one of the area of one of this triangle, so triangle AEO, we have half, then 8 times 8, which is my two sides, and then sin of 72. And if you look at your drawing here, we can see that I've got 1, 2, 3, 4, 5 congruent triangles. Therefore, I can just simply multiply my triangle formula. This is my triangle formula by 5 to get the total for all 5. Okay, so we have half, then side times side, which is 8 times 8, sin 72 degrees. All right, and that we multiply by 5, and that gives me 152.169. So we're going to round to 3 significant figures, which gives me 152 degrees. Okay, then in question B, they say a rhombus with an obtuse angle of 130 degrees has the same area as the pentagon in A. Find the length of a side of the rhombus. All right, make it easy for yourself. Do a little drawing. We know that this angle is 130 degrees. Again, people, this is the only information that is given. If we then draw the diagonal, we can see that we've got two triangles. We've got triangle LMN and we've got triangle KNL, and we know that those two are congruent once again. We know that in a rhombus, the side length is equal, so we can make that x. All right, and to now calculate the area of this, we have got the area of the pentagon, which is the same as the area of the rhombus. But if you get the rhombus, firstly, people, we've got two triangles. So we have 2 times. Then we have got again half of the two sides, which is x times x, and then sin the included angle, which is 130. Okay, so to get the area for this triangle, we have half, okay, the two sides, which is x times x, which is x times x, and then sin of the included angle, which is sin of 130. Okay, and if we do the calculation here, 2 times 1/2 is 1, so that's x squared sin 130. And now remember, the area of the pentagon is 152.17, coming from question A. Then if we do Goro's we're going to take over the sin 30, we're going to take the square root, and that gives me a side length of 14.094, and that we round to 3 significant figures, which is 14.1 degrees. So this is a question where twice, people, we apply the formula for area is half 2 sides sin included angle. Okay, half times the 2 sides, okay, meaning the side times sin of the included angle. That formula you must just simply know and apply in this example.